All right, welcome back. This is the Borderless JS conference, the second day, and we are actually doing just fine. So I hope that you enjoy this conference. Feel free to post all your comments, all your questions, all your notes into the comment section. And how about we explore further, right? Because we are borderless JS conference, we don't have any limitations, we don't have any borders. So right now we are switching from the business aspects to some AI aspects of the development, and we're jumping from another location to another location. And now we have our next speaker from London. So Konstantin will give you a quick and detailed overview about the practical LangGraph JS. So get ready to see all the best practices in the development the GenAI application with the LangGraph. Over to you.
Awesome. Thank you, Pavel. Thank you for introduction. So actually today we're going to be a bit of a crazy talk. Initially it was supposed to be talking about practical LangChain actually, but in the process of preparing the talk I actually realized to change it, and I'm going to talk about it in just a second. But first let's start with who am I, and basically I'm a Konstantin Perikov. I goes by Kos. I'm a principal software engineer at EPAM, working for just a bit over 7 years now. And as a main work activity, apart from engineering, I'm leading a search competency center of excellence, where we're doing a variety of different search-related information retrieval, natural language LLM type of projects. And we actually were doing Gen AI and rather large language models before it was cool and hype in 2022. So, for example, in 2019, we were doing some of the chatbots for one of our actual internal EPAM conference, having ability to answer questions. And this is some links on my social medias and GitHub. To be honest, most interested to me is if you could subscribe to me, follow me on the GitHub. It would be super awesome, actually. But yeah, let's dive deep into what's this talk supposed to be initially and why I changed it, and let's dive deep into this one. Basically, I originally was supposed to be talking about a LangChain JavaScript version of it, and just to be full disclosure, I'm not in any capacity would call myself a JavaScript expert, but I really wanted to talk to you about some of these amazing and very breakthrough type of frameworks, libraries such as LangChain. And LangChain consists of a lot of different tools like, LangChain Core, Community, and et cetera, et cetera. But basically, as I was preparing the content, as I was writing like the POC that I was using LangChain for, I more and more start looking into agentic approaches lately, right? So this is where I decided to actually change it to the LangGraph JS. So I was actually doing some very stupid, very naive type of thing when I replaced the chain with the word graph. And this is how I got this very nice marketing promotion. So today we're going to be actually looking into LangGraph, and I hope you're going to like. If you were here to listen about LangChain, so sorry about that, but if you were, I hope you will be liking actually LangGraph part of it as much as I would do as well. So let's start with some very baseline type of examples why we might need to have some specific large language based applications. And I wouldn't go into RAG, to be honest, today, or any other advanced approach like hybrid search approaches, maybe content generations, using large language models as critiques and everything. So I think I'm focusing on more or less straightforward software type of development projects. And in this case, the one would be super simple. So let's write maybe an application that would go and get some pricing, for example, for some stocks symbol. Let's say let's check the EPAM price for the stock, for example, and let's say ask large language models to make any sorts of conscious decision around that. For example, should we invest? Maybe should we not invest? Should we sell? Should we buy? And of course, in reality, it's much more different, as you could imagine. But let's have this as an assumption that we just want to create a naive financial trader type of application based on large language models, right? And in order to do that, we could have a different components out of it, right? So if I would go very quickly to my WebStorm in this case, I've created actual repos on the GitHub, and I will share the links later, which you could take a look after the call, after the session. But basically, this is the simplest one, right? So we got some specific libraries, we set up the OpenAI library coming to do the request to the OpenAI. We got some Axios to do the HTTP request in this case. And very simply, we're just doing and go into this Alpha Vantage service, which allows us to get some trading, some stock price for specific stock symbol. All right. And yeah, we just do some simple parsing here and return it as a result. Right. So then the next step would be let's ask OpenAI, for example, about some specific model. In this case, we're using Omnius Mini model, which is kind of powerful but relatively cheap. And once again, we not get bothered right now for the sake of this exercise into what are the actual prompt, what kind of system prompt should look like. This is nowhere anywhere close to the actual good prompts in any capacity. But I think it would work just fine as an illustration. And we're just asking, what does stock price, mean for this specific stock symbol? Is it good? Is it bad? And after all, we just combine it all together in some async promise variation where, for example, we select the stock symbol, let it make EPAM, we get the stock price, we get the AI response, and we just open it out, right? I'll output it as a result. And sorry if you see some of my coding part. But anyway, and like I'm not gonna even run it, to be honest, because it's super straightforward. You're gonna get some response from OpenAI, and that's it, right? So nothing really you could do. So this is our baseline examples, and what's this approach have in common, right? So we have a specific call to the remote API, in this case HTTP-based remote API, right? So sometimes it could be called a tool in a LangChain and overall in the GenAI type of space. And then I think most importantly, we ask and do once again, it's in its nature, it's HTTP call where we do the call to the OpenAI to get the stock symbol, to get the price, to get some analysis out of it, and we return it as a response, right? But then I think, and so far I think it's once again super straightforward. I'm pretty much sure a lot of you were playing and even maybe delivering real projects, POCs, demos to our clients. If you looking at us externally outside of EPAM as well, you could do it maybe for your clients, for your projects, for your development. Absolutely, this is very basic. Once again, I'm not even discussing it deeply. But then I think very important is this, type of comment. We get this response, right? We got this response from AI, which would be something, right? And what if we want to do something based on this LM response, right? What if we want to actually maybe start trading, selling, notifying somebody? Right. And to be honest, this is often a lot of people use as a motivation for agentic. And to be honest, I'm a bit skeptical, right? If this is enough to actually be motivation for agents actually, because there is a very simple thing as a concept in the LangChain, and it exists across JavaScript version, Python version, wrapper, and every other wrappers basically. And yeah, chain is basically a solitary model, where we could, just not just do the calls to the LM itself. It was a second step, but we also could do the step number one, for example, right? We could do the pre LLM call in this case, right? So we could maybe tool calls in this case, right? So tooling is exactly something which is outside, and HTTP is definitely a good example of tool call, right? So this is the step one. Then we call an LLM, and then let's say step N, we're making some sort of decision. And in this case, this control flow to some extent just forms into a chain. Hence the framework is called LangChain, right? It's like a language chain. And don't get me wrong, like this these control flows, these chains are very much reliable, right? Like they would have a same control flow over time. There is a predefined steps, they go one after another, and that's fine, right? Probably we don't need even agents here. We could, for example, take a look into this LangChain example, right? So if you would go just slightly updated, right? So previously it was purely using Axios and OpenAI library to do the calls to the OpenAI, right? But then if you go to the LangChain, like if you go one step further, one step deeper, we still have exactly the same stock price tool call, right? It didn't change at all. So model here, it's a bit defined now differently, right? So we're using the nice abstraction from the LangChain OpenAI, where basically we could import it, we could create actual model, we could specify what kind of API keys we're using, what kind of model we want to call. And now the prompt would go from the previous JSON example into actually chat prompt template. Once again, some nice abstractions coming from LangChain in this case. And we actually could create this chain, right? So which would be super straightforward. Once again, prompt, pipe to the model, pipe to string output parser, right? And here, it's almost exactly the same. The result would be almost identical, I would say. We're going to get the stock price, we're going to invoke the chain, and we're going to do something with it once again. So one of the straightforward version, and I see it when the ChatGPT hype start appearing in 2022, we start doing a lot of different projects. And we start doing how we're going to parse this response, right? So one of the naive, of course, and very simplistic implementation would be, hey, let's select if there is a word maybe positive outlook, maybe other type of thing. So we could execute some code for specific positive outlook, for example, or for negative outlook. And of course, as you could imagine, there is a lot of challenges with this approach, right? You never know if the words positive actually will be there. Will it be written exactly like this? Maybe we're going to use the synonyms, different meaning, etc., etc., etc. So it all creates a bit of a challenge, but we still want to have this decision type of making. All right, and yeah, this is just an example of the code that we already do this, right? And the next step would be, hey, let's do something with this response, right? Like maybe we could get response in some specific form. Once again, pretty much simple idea, very popular idea, where we would say, maybe I want to have some sort of a router type of activity. So maybe based on this chain, once again, at some point, large language model will make, let's say, a decision if you want to go to step 2 or step 3. So this is a bit of start getting a little bit agentic, right? So LLM kind of maybe making decision. But in our case, in our very simplistic case, we could even replace this LLM making decision with just if else type of thing, right? So we could just maybe look for specific part of the response and make this routing decision without any technically LLM, right? It's just enough to have the actual response of the analysis from LLM. And then yes, definitely we could do this as well. So we're adding a little bit more abstraction. I think one of the important ones is actually structured output parser, right? So we're going to see how to use it a bit later. So we get in the stock price the same, we get in the model. I think funny part that we did the zero in the temperature here, just not to be too creative in the response. And we're using this nice Zod library, which is quite popular, I think, in the JavaScript domain. Let me know what you think about it. Once again, I'm not an expert. I just saw somebody using it in LangGraph and LangChain ecosystem, and basically we're explaining what would be the schema of the response, right? We want to have a response with some specific a positive, negative, neutral type of thing, and some specific recommendation, right? So it would be some specific recommendation based on this analysis. Our prompt is getting a bit more complex, but overall it stays the same. And once again, we're using this structured output parser from this one. So how it looks like, how the main flow looks like right now. So we still stay with stock symbol, we're still getting the price. We're getting the response now out of the chain, right? So we're now getting actual response, which would have a format instruction. And yes, we could log answer, outlook, recommendation. And now this is actually much easier, right? We don't do any regular expression parsing type of thing. We're not doing guessing, like the synonyms or all the words which would imply the positive trend versus the negative trend. We just ask basically ChatGPT, LLMs in this case more broadly, to output us some structured response, right? So something which would be parsed as a JSON and would have some fields, some objects with some fields specifically, which values we could compare. And now it's much easier to some extent because we could do this type of routing thing when we select the field, we select the value, and we're executing some code, for example, for positive or negative outlook, or maybe even for neutral if it's not mentioned. And to be honest, this is quite well working approach overall, you could say, right? It's working in most of the cases. However, I think the challenge here is, and everybody who's actually spent a bit of time with the large language models trying to answer in a structured output format, in a JSON format, have this. So, like you run this, it's working great, but then once out of 100, once out of 1,000, you get some specific hallucinated, you could even say, type of response, right? So response when JSON wouldn't be valid, or it's going to fail, or it's not going to be using positive or negative. It's going to just write something very similar, but not exactly the same, right? And it goes on and on. And this is actually where I'm feeling more and more motivation for the agentic, right? Because chains in this case are once again great tools, definitely could be used. But for example, we see that there is no dynamic decision making, right? This is very important motivation for this. Sorry, just go to my slides. So like there is no dynamic decision making here, right? So it's once again if else, pretty much structured into the code. LLM actually in this case not making decision, is us who make the decision, maybe based on some response from LLM, right? So it's once again, it's giving us the output based on some specific prompt. We get it and we decided that this is a kind of decision type of thing, right? So there is not much of the feedback loop, right? For example, so if we want maybe to invest something here, and maybe we want to invest a specific type of evaluation through the actual human in the loop, for example, it would be very challenging to put it into this chain, right? Or how we could make sure that there is like some specific human validation, right? So there is no ability for LLM to receive this type of feedback, right, and maybe refine its response, maybe rerun it once again, maybe rerun the analysis of the stock price. Of course, similarly, there is no self-correction. Once again, LLM could not correct itself if it produces an unexpected output once again, right? So all these challenges and many more, of course, this is, I think, where the motivation for agentic approach is actually start making more and more sense. And today we're going to be actually looking into some of the foundations and some of the examples of LangGraph. And LangGraph in this case is a library for building stateful multi-actor applications with large language models, right? It's used to create not just one but multi-agent workloads, how they're going to communicate with each other. So in order to compare it with a lot of other LLM frameworks, specifically LangChain, for example, this offers some additional core benefits, right? It could have some cycles. It could have some controllability. It could have persistent as a type of memory, even though I know memory exists in LangChain as well. This is one of the things that LangGraph is adding. And it's to some extent, when working with this and writing the code for the LangGraph, I actually realized that it's kind of low-level framework. It actually gives us a little bit of more control over the state of the flow of your application. You could define the graph of how communicating and kind of communication between the graphs could work. Yeah, so this is it. And what are some other features, I think, just to make it clear? So yes, it's have integrations overall, like this LangGraph, LangChain, LangSmith, right? It's all goes into this one ecosystem which we have. And actually, let me go back quickly to the appendix. Yeah, so technically this is the whole ecosystem of Lang something, I don't know, Lang framework you could call, right? So because we have like LangChain and LangGraph, which is open source components, we have different integrations, which once again are open source. But then we have LangGraph Cloud, so ability to deploy these agentic systems into the cloud, as well as LangSmith, which is providing nice debugging, playground, prompt annotation testing, etc., etc. So it's a variety of the different components that we have. So, and conscious of time a bit, let's dive and see how we could make this agents example even more complex, because I think for now we're just having maybe not enough we have not enough agents to interact with each other, right? Because we have rather like a tool calling, but instead let's replace this with actual with the actual agents behavior in this case. And I'm gonna just jump into the code again. So now the code is actually much more code you could see. We installed the LangGraph. Once again, the README contains more or less the basic way how you could install. So LangChain, LangGraph, LangChain Core, and some of this one is actually API keys that I'm going to be using, but not for OpenAI. So you could take them if you want. And basically, what we're doing here, we're getting the keys again. How the LangGraph approach is different from the LangChain. So here we need to define the agent state, right? So we have what would be used as a part of the state for the engine. So it's a messages, right? Because we're still building some sort of a chatbot. We build in the memory where we could store, for example, in this case, the previous prices. So the previous price on the previous run. So we could include it into analysis, and we could have understanding what's the next point in our agent state it is. And here, instead of getting the function for getting the price, we a little bit change it. So now it's actually called the dynamic structure tool. So it's have a specific name, right? So it's have a description what it's getting out of it. But internally, the implementation is very much close to the previous one, right? So we get in the API keys. We go to this Alpha Vantage API. We're using the Axios respond. Boom, boom, boom. We get the stock price. Perfect. After that, we also want to define what type of engines we have. And in this case, we have only 3 agents. So it's a data fetcher. So some agents which are going to use this stock price tool. The analyst, which is going to be doing the call to the OpenAI in our case and making a decision of like what should be done. And we have a reporter who is making some sort of kind of report based on the pricing. So it's a bit of a premature agent, I think, but just for complexity, I've added it. And we have a supervisor actually. So in this case, we're already talking about variety of agents talking to each other. We, for example, have a specific routing tool which supervisor is actually making. So basically, every time we go to the supervisor actually making a decision. So who should act next? Like who is the next role, the next agent that should be working? Formatted out prompt, I would just skip it. Here we just define the OpenAI model again, and this is the supervision chain that we define. Yes, so for the supervisor agent in this case. So you're saying that LLM, binding the tool, it's going to the routing tool, which once again making a decision who will be the next, what will be the next role. We just output it as a JSON. The node itself is very much just a definition and a lot of the different boilerplate code. For the data fetcher agent, we actually once again define the LLM. We define the tool. In this case, it's a different tool. It's a stock price tool now, right? So we see it's a different, and we have some system message once again. Pretty much, very much a simple system message data fetcher type of thing. And this is analyst agent. So analyst agent once again doesn't have any tools in this case, right? Because it's not going to be doing anything. It's just analyzing the stock symbol, the stock price, and making some recommendation. And we get in just some response where we invoke it with some specific human message as an analyst. Reporter just summarizes, in our case, the analysis, once again, not using any tool. So it's a little bit simple type of agent. So after we defined all of these four agents, actually, we now know what to do next, right? So the next, we actually need to define the state graph, right? In this case, we have 4 nodes, very simple graph where we have data fetcher node, once again, doing the calls and using the tool to do the API call. We have analysis which doesn't have any tools but do the LLM call to do the decision. Reporter, who is kind of like summarizing it for the news article paper, for example, and supervisor, which is actually making decisions how they should be run. We start with the supervisor. So supervisor is the first node which is actually starting. So we had this edge from start to supervisor. So supervisor is the first agent that's going to be acting, and it's making a decision who to call. And overall, we just assemble it all together, and stock symbol once again EPAM. And yeah, let's take a look how it's running. Hopefully, it will work. So we're using npx and ts6 in this case to just run it LangGraph. And yeah, so supervisor making a decision to call the data fetcher next based on it. Data fetcher actual goes to use the tool, and it's got the price of the EPAM stock. In this case, it's 192. Sorry, 192.77. It doesn't have any specific previous price, so there is some output of LLM you could see, right? And then supervisor making a call to the analyst, right? So analyst using this price, using this output from the data fetcher, actually making some sort of prediction, analysis, etc., etc. So it goes into the memory right now. We could see it into the memory. And then supervisor just basically after that makes a reporter to be the next, and reporter make it a little bit, once again, newspaper. And after that, actual supervisor understands that it's enough work for now, and we should be just ending this whole thing. Once again, I'm terribly sorry, and I know we're running out of time, so I will just show you what's the real, more or less real application would look like with the cycles and memories and making a decision. And actually how it's happening, we updated the pricing with some getting previous close data. We still have the supervisor who is making a decision, still using the route. However, supervisor additionally adds this specific behavior that if the state of memory of the outlook is neutral, and the next person to do the activity is actually investor agent. So now we have much more agents. We also have investor agent, which would be able to buy or sell stocks, for example. But if you see the neutral outlook, we understand that investor shouldn't be really doing anything, and it should go to the waiter agent, which will just wait until you would be able to behave. And what's going on? My WebStorm is done. What? Crazy. Just really wanted to show the last one before we go. Oh yeah, sorry. I don't know. My WebStorm just frozen. And yeah, so we have also reporter node is the same. So we have now the waiter node, which is actually behaving when we are waiting for evaluation, for example, of the analysis, and waiting for just 1 minute. Of course, it's hard coded, so forgive me about that. But now our workflow is much more difficult, right? We have data fetcher, we have analysis, we have investor, we have reporter, we have supervisor, and we have waiter. But overall, it stays the same. And let's just make it run. And this would be the wrap, I think, for this one. So once again, supervisor deciding to call the analyst now. Imagine, you see that this is different a bit. So supervisor not call the data fetcher, but call the analysis instead. And analysis provide the response like this. It seems that the stock price are not provided, right? Because we didn't get it when we started, right? So, and basically analyst saying, hey, I couldn't perform the analysis without getting the price. So I'm out of it. So supervisor, based on this response, actually realize that we don't have a data of the stock symbol. So we need to go to the data fetcher. We need to go to the actually getting the stock symbol, right? So data fetcher goes there, and it's actually getting the content, right? It's getting the latest price, the previous price. So now supervisor is understanding this. Like, okay, I see in my memory I actually have the stock price. I could go to the analyst now. Analyst provides their recommendation, agentic recommendation, and outlook in this case is neutral. And you could see that neutral outlook received, so redirecting to waiter to wait until the next call would be done. And you could see this is 60 seconds counting down to the 1. And now we call in to the waiter again, and probably going to wait a bit more. This is actually funny because supervisor at some point might think, hey, I want to do waiter a bit more and not call the data fetcher as well, because once again, they could think that 1 minute is not enough. And I'm afraid this is it. I'm already running out of time. So I hope it was as much fun for you as it was for me. And this is examples of the code that we looked into the actual. And yes, I will just leave it here. So if you want to take a look into actual examples, once again, pretty much fresh POC using LangGraph, but I think it was pretty cool. Ability to interact between the agents showcased both complexity of this approach and sustainability to like support complex scenarios. For example, yesterday when I was like doing some crazy final adjustments, one of my API keys for Alpha Vantage wasn't working properly, and agents was actually like detecting this quite nicely and didn't like retry all the time. Instead, they understand that something happening with this data pricing tool. So instead, they were like trying to skip it or wait for a bit more, and which I think was pretty funny. So once again, this QR code is leading to my GitHub repo. If you have any questions, I'm afraid I wouldn't be able to answer them right now on the session. Please post them into the chat. We're gonna have them on the VR community, and I would be happy to actually answer all of it after this session. So thank you very much, and yeah, that's it for now.
Yeah, thank you, Konstantin, for your talk. Really, really fun talk. A lot of details, a lot of examples, and thank you for posting the link as well so we can explore it. Yeah, good stuff that you've mentioned that you are happy to answer all the questions later on. Nevertheless, just a quick one, right? So what if we really have sort of like conflicting and incomplete data, right? So what strategies can developers use to ensure reliable outcomes in such situations?
So retrying is one of the differently one of the options, right? So like if you're going to use it multiple times, there is a chance that it's going to work. Making the temperature 0, I think, worked for some of the people to make it less creative and more stuck, more grounded to some extent. But overall, to be honest, my answer would be like, if you have not such a great data, you need to fix first your data. This is to be honest super critical. Amount of projects, activities that you have when you have like a garbage in and type of garbage out situation, it's enormous, and no LLM, I think, at least maybe in this generation, would be able to solve this without actually fixing this data. So LLM actually could be quite helpful in data quality detection, in data quality issues detection, maybe even fixing it specifically. But you need to do this before you go into more specific RAG pipelines, maybe search pipelines or any other analysis pipeline.
Yeah, makes sense. Makes sense. Thank you very much, Konstantin. Again, guys, if you do have any questions, just drop them into the comments section. And yeah, feel free to enjoy other talks as well. Thank you and bye.
Thank you. Bye.